Definition. If c is in the domain of the function, and either the derivative of the function equals 0, or the derivative of the function does not exist where x equals c, we say that c is a critical number of f. If c is a critical number of f, then the point cf of c is called the critical point of f. Example. Let's find the critical point in numbers of x to the power of 2 minus 4x. First we will differentiate. Now if you look at the definition, one sort of critical point is the one for which the derivative is 0. So I would like this to be 0. Or I want this to be 0. Solving for x, I get x equals 2. And I get that the critical number is x equals 2, and the critical point is 2f of 2, which equals to negative 4. A polynomial is differentiable everywhere. It cannot have a critical number of the type in which the derivative does not exist. Let's now use graphs, and again, there are two types of critical numbers, one for which the derivative is 0 and the other for which the derivative does not exist. Let's start with derivative equals to 0. In this case, the slope of the tangent line to the graph at that point is 0, which means that the tangent line to the graph is horizontal. Example. If you observe the graph of this function, it has 2 points for which the tangent line is horizontal. Here is one, so this is a critical point, and here's another critical point. So we have 2 critical points for this specific function of this sort. If you look, this function is differentiable everywhere, because we know already how to observe graph to find out if a function is differentiable or not, and this one is differentiable everywhere. Now let's focus on the other kind, when f prime c does not exist. This means now that the function is not differentiable at x equals c. And I want to recall, there are two kinds of non-differentiable functions. If f is continuous at x equals c, it must be a corner, which means that the right and the left slopes at c are different, or vertical tangent line at x equals c. And also, if the function is not continuous at c, but c is in the domain of f, then also the function is not differentiable at x equals c. Let's now observe this graph. You can see that first of all, here you have a tangent vertical line. Here you have a corner. And here the function is not continuous, but observe, this point is a point on the graph, which means x equals c there is in the domain of the function. We have 3 critical points here because f prime c does not exist. But also, if you observe, we have also the first kind, because here there is a horizontal tangent line. So we can conclude we have 3 critical points where f is not differentiable, and we have 1 critical point where f prime equals 0. Let's try now to find all critical numbers of function f without the graph. First, we need to differentiate the function. Then we need to observe a few things. First of all, we should find all the numbers such that f prime x, the derivative of the function, equals 0. And they are in the domain of f. This is very important. Now the other kind, which is more complicated, we have to find all the numbers that are in the domain of the function and not in the domain of the derivative. Or all other numbers for which f is not differentiable for any reason. And you know the reasons, because we discussed that before. Here is an example, cubic root of x. We always start by differentiating the function. Now we really like to observe the function. So we know that the derivative cannot have x equals 0, but x equals 0 is in the domain of the function because the domain of cubic root of x is the set of all real numbers. So now let's go and do more details here. First of all, this guy can never be 0. Well, I want this to be 0, but it's impossible. A fraction is 0 only if the numerator can be 0, but you have 1 and 1 cannot be 0. So the derivative of this function is never 0. So we have to inspect now the other kind. And we already know x equals 0 is in the domain of the function, but it's not in the domain of the derivative. And f is differentiable for all other numbers in its domain except the x cannot be 0. So we can conclude that there is only one critical number, x equals 0, and the critical point is 0 of 0, which is 0, 0. Here are some special functions. We know that the domain of the polynomials and their derivatives, because the derivatives are also polynomial, is the set of all real numbers. So if we want to find the critical numbers of differentiable everywhere functions like polynomials, like sine, like cosine, like e to the x, then we can really shorten the process by a lot. So first we will differentiate the function, but then we only need to do this because we don't need even to check that the derivative is indeed 0 for value that it's in the domain, because it's clear that if that derivative is 0 for some value of x, it is already in the domain of the function. But even more, we don't have to care about those guys, because f is differentiable to all real numbers, so we cannot have this type of critical number. So if a function is differentiable everywhere, there is only one type of critical number or numbers. So you have to differentiate, and you find all the numbers such that f prime x, the derivative of this function, is 0. For example, this is a polynomial, so I just need to differentiate, and I would like to solve this to 0, so I want this to be 0. Please don't forget all the algebra that we learned in the first chapter on precalculus. And I get not only that x equals 2 and negative 2 critical numbers, but I know that those are all the critical numbers, because there are no other solution for the derivative to be 0. So the critical point is the whole point. It's an x and y coordinate, so it's 2 and f of 2, and negative 2 and f of negative 2. To get f of 2, you substitute in the function. Be careful. Many functions are differentiable everywhere, but they are losing this property if they are composed with other functions. For example, sine x is differentiable everywhere, but sine of 1 over x is not. Be careful. Being in the domain of the function is a requirement for c to be a critical number of f. If c is not in the domain of f, then it cannot be a critical number of f. Let's do an example. Here is the function 1 over x minus 5. Here is the derivative of this function. You can see that this is never 0. But x equals 5 is not in the domain of the derivative. But it's also not in the domain of the function. So it cannot be a critical number. So we can conclude that this function does not have any critical number. There are many functions that don't have any critical numbers.